We just finished looking at square roots and how we can go back and forth between exponents, squares, and square roots. So in this video, we're going to be looking at different types of numbers. There's lots of types of numbers. There are integers, which we've already talked about a little bit. And then there are the random sets of numbers. There are numbers called vampire numbers. There are numbers called happy numbers. There are numbers called melancholy numbers, which are like sad numbers. There's all sorts of different types of numbers. Some of them are useful, like integers are very useful. Some of them really aren't useful. They're just kind of fun, like vampire numbers. They're not useful. You can look it up. Go to Google, pause it if you want, go to Google, look up vampire numbers. They're out there. There are narcissistic numbers. There are amicable numbers. There's all sorts of different types of numbers. We're just going to look at a couple today. And these are the more useful numbers, the ones that really affect things. And so, and trying to keep it short, so I'll be quiet about that. We've got this diagram here. We're going to fill this in. And with different types of numbers, we're going to talk about how they work together. Some of this is going to be like a square is a rectangle, but a rectangle is not a square. That type of thinking, where a square has 4 sides and 4 right angles, and that's what a rectangle needs to have. So a square is a rectangle, but a rectangle is not a square, because to be a square, it has to have 4 sides that are the same and 4 right angles. Rectangle doesn't necessarily have that. So we're going to look at how that works here. First type of numbers, in the innermost circle here, the smallest group of numbers that we're going to be dealing with today are called the natural numbers. And there's this fancy n that we can use as a abbreviation.
Luke Olson, if you are in the building, please go to room 206. Luke Olson to room 206.
I don't know if you could hear that, but Luke Olson, go to room 206. All right, so natural numbers. Natural numbers occur in nature. So like there's 1 desk, or there's 5 students, or there's 22, I don't know, things. And so natural numbers occur in nature, and they are positive whole numbers. And that is the smallest group of numbers that we're going to be dealing with. So from 1 to infinity, that's the smallest group of numbers. From 1 to infinity, positive whole numbers. Another type of number are what are called the integers, and that's a fancy z. I don't know why it's a z, but it's a fancy z. And those are the integers. And those are all the positive whole numbers and their opposites. So like 1 is an integer. Right here, 1 is an integer. It's a natural number too. It has 2 names. It's a natural number. It's also an integer, because an integer is all the positive and all the negative whole numbers. If it's a positive whole number, or if it's a negative whole number, we can call it an integer. 5 is a natural number, and it's an integer. Negative 22 is not a natural number, because it's not a positive whole number. It is an integer. So it counts as an integer, but not a natural number. So basically, anything inside this circle here, if I pick a number right there, we'll pretend that's a number. It's inside this natural circle. It's a positive whole number. It's also an integer. So the way this diagram is set up, the way this graphic organizer is set up, it works outwards. Everything in the innermost circle is also, so that point right there is also inside the integer circle. And I know they're ovals, but we're going to say circle. So it's inside both of those circles. So it counts as both names. It's like saying that an ape is a mammal and it's an animal. And it's an ape. It's got 3 names. In fact, we've got more than 1. We've got more than 2 names for things. So let's keep going out here. Go to the next step. So that's the next smallest set of numbers. Negative infinity to infinity. All the positive and all the negative whole numbers is our next bigger group. But it's still not the biggest group yet. Next biggest group are called the rational numbers. And the rational numbers have a fancy Q. I don't know why it's a Q, but it's a Q. So a fancy Q is our abbreviation. You don't have to remember the Q. You just have to remember rational, integer, natural. But if you want to abbreviate, you can use those symbols. Rational numbers are any number that can be written as a fraction. So like 21 sevenths, that's a fraction. Negative 10 elevenths, that's a fraction. 4.5, you could rewrite that as 4 1/2. So a decimal that stops could be written as a fraction. If it was 4.52, that'd be like 4 52 hundredths. 4.53, 4 523 thousandths. So any decimal that stops, you could write as a fraction, because you can say the words 4 5 tenths is 4 and then 5/10, 5 tenths. So that's a fraction. A decimal that repeats could be written as a fraction. 0.333333333 is 1/3. So if it's a decimal that either stops, like 4.5, or repeats, like 0.333333333, those are rational numbers, because you could write it as a fraction. Let's look down here though. Let's look at 22. 22 is a natural number because it's a positive whole number. It's also an integer because it's a positive or a negative whole number. So 22 works its way out. It's also an integer. You could write 22 as a fraction, 22/1. So 22 is also a rational number. Now it has 3 names. 22 could be named natural, it could be named integer, it could be named rational. It's got lots of different names that we can call it. It fits into all these different categories. An integer, -1. You could write -1/1. That's an integer. It's also a rational number. -1 is a rational number. So it works its way out of this graphic organizer we have here. The next one, the real numbers. I mentioned earlier that there are other types of numbers, but the real numbers, and the real numbers are all the natural numbers, all the integers, all the fractions, and all the decimals that stop. And then it includes these weird numbers, like irrational numbers. Irrational numbers are like pi. Pi is an irrational number. Pi is 3.14159, blah, 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 blah. It keeps on going forever and ever and ever. It never repeats. It never stops. The square root of 2. The square root of 2 is, well, it's not 1, because 1 times 1 isn't 2. It's not 1.5. 1.5 times 1.5 is 1.25. Or excuse me, 2.25. There is no square root of 2. If you type it in your calculator might round and give you an answer, but it will never, ever stop. Nobody knows what the square root of 2 is. Nobody knows what the square root of 10 is. Nobody knows what the square root of 11 is, or the square root of 12, or the square root of 13. If it's not on our list of squares, if it's not a nice whole number answer, it's irrational. Because it never stops and it never repeats. It's really weird. And those are the irrational numbers. There's no special symbol for irrationals. So irrationals are kind of like their own little bubble. And it doesn't work out. So a rational number cannot be irrational. And a way to think about that is, so rationals and irrationals, a rational decision would be like walking up to a cliff and turning around and going back. That's the rational thing to do. An irrational decision would be to walk up to a cliff and jump off. That's irrational. It might be more fun, but it's definitely irrational. You can't be both rational and irrational at the same time. You can't jump and not jump at the same time. That doesn't work. Let's do some examples here. Let's do some examples, because I feel like we need to see some examples before I bog you down too much. All right, let's skip this one. I'm gonna go over here first. We'll come back to that first one. We're gonna write all the classifications, all the names that apply to each real number. All right, so that's the idea here. So 18. And actually, you know what? Pause it. Try this first. If you have no idea what to do, then just keep watching. But pause it. Try it if you think you know. Okay, I'm going to go through this because I know it can be confusing. 18. 18 is a positive whole number. So it counts as a rational number. We can call it a rational number. So that is, or excuse me, a natural number. So I'm going to be lazy and I'm going to use the fancy n. But that's a natural number. Okay. What else could we have it be? Is it a positive or a negative whole number? Yes. 18 is a positive or a negative whole number. So we can also call it an integer. I'll actually write the words, I guess. Well, let's see, could we write it as a fraction? Could we call it a rational number? Yeah, 18 over 1. Now it's a fraction. Now it's a rational number. Okay, yes, I'm going back to the symbols. I'm going back and forth today. All right, let's look. Could we call it an irrational number? No, because you can't be both rational and irrational at the same time. We know what it is. It's a fraction. It's a rational number. And of course, it is a real number as well. So it's a real number. All right, let's look at 8/9. Is 8/9 a positive whole number? No. Is it a positive or a negative whole number? No. Is it a fraction? Yes, it is a fraction. So that is a rational number. And it can't be both rational and irrational at the same time. And it's also real. It's also a real number. Last one I have here, the square root of 20. All right, let's see, the square root of 20. Is that a positive whole number? Well, let me look back at my list of fractions, or of squares and square roots. I know 4 times 4 is 16, so the square root of 16 is 4, or negative 4. I know 25, the square root of 25 is 5, or negative 5. So 16, I can take the square root. I'm either going to get 4 or negative 4. 25, I can take the square root. I'm either going to get 5 or negative 5. 20 is somewhere in between, which means we're going to get some crazy weird decimal. And that's never going to have an end. There will be no decimal that ends. So if you can't take the square root and get a nice number, like the square root of 25 is 5, square root of 16 is 4, it's irrational. And that's the way you can tell. If you're not sure if it's going to be rational or irrational, or what irrational numbers would be, if you can't take the square root, that's an irrational number. There are other irrational numbers like pi and e and some other weird ones. But basically, for what you'll need to remember for now, square root of a number where you can't do it and get a nice answer is irrational. Pause it, try these 4. See if you can figure out if these statements are always true, never true, or sometimes true. I'm going to assume you paused it. I'm going to keep going here. Ooh, I'm already at 12 minutes. That's a little bit longer than I want to be. Natural numbers are rational numbers. Yes, all natural numbers could be written as fractions. So this is always true. All natural numbers you can write as a fraction, so they are rational. Negative numbers are integers. Not necessarily, because the negative square root of 20 is not a rational number. It's definitely not an integer, so not necessarily. Same thing with the negative 1/2. That is not an integer. So this is sometimes true, because you could have negative 2. That's an integer. But negative numbers are integers sometimes. But there are examples where that's not true. Mixed numbers are rational numbers. That is going to be true, or always true, because a mixed number you can write as an improper fraction. So if you have 1 and 1/2, you're going to have 3/2. That's a fraction. So any mixed number is going to be a rational number. So that is going to be always true. And you wouldn't have a mixed number with a square root. So that you just wouldn't do that. Real numbers are integers. Sometimes. Some real numbers are integers, but some real numbers aren't. Just like here, negative numbers are integers. Some negative numbers are integers, but we found some negatives that aren't. So some real numbers are integers, some real numbers are not. So this would be sometimes. This takes practice. It does. It takes a lot of practice. So at this point, if you've only done 3 examples and you're still a little fuzzy on it, that's okay. We need to keep practicing. It takes a lot of practice to get good at figuring out what type of number is